All right, in this lecture, we're going to start talking about connective tissues, and particularly we're going to focus on fibrous connective tissues, and I'll explain what that term means in just a second. The general functions of connective tissues, like if we take a look at all connective tissues, what do? Well, they are connective. They bind things together, right? They're what binds organs together. For instance, you can bind one organ to another organ, like tendons, which are going to bind bones together, are going to bind bones to muscles, and ligaments, which are going to bind two bones together. A bone, or a muscle, by the way, is an organ. Support bones themselves are connective tissue, as are cartilage, and both of those are things that give structure and support to your body. Physical protection, so your skull, your rib cage, pretty much all of your bones, those are going to protect you from damage. Fat is a type of connective tissue. It provides padding as well as other things. Most of your body's physical protection is due to connective tissue. In addition to physical protection, also immune protection. Blood is a connective tissue, and your immune system is primarily made out of white blood cells, which are, again, connective tissue. And your non-blood immune tissue, your immune system organs, things like spleen and lymph nodes and things like that, those are mostly made out of reticular tissue, which is another type of connective tissue. Movement. So muscles provide the force for movement, but if you did not have bones, all you would be was a twitching, quivering mass of contracting muscles. Your bones are what provide the lever system, allowing you to move your body in different ways. Storage. Fat, calcium, phosphorus, other things. Many things are stored in connective tissue. Fat cells at adipocytes obviously store fat. Calcium is stored primarily in your bones, as is phosphorus. Heat production. You actually have a specialized type of fat cell called brown fat, and brown fat's job is not what you would normally think of for a fat cell. It's not primarily there to store fat. The reason why it's brown is because it has a bunch of mitochondria. What do mitochondria do? Well, they make energy. And these particular brown fat cells, they're actually not there primarily to make ATP. They're there because when you make energy in the mitochondria, you produce waste heat. That's what heats you up. And by burning fat, they increase your body's temperature. This is particularly true in small animals, as well as humans when they are in their tiny stages, particularly in infants. Transport is an important part of connective tissue. Things are connected to other things by means of your body's highway system, which is basically your blood, which is a connective tissue. There are 4 types of connective tissue. We're going to be talking about some of them, most of them today. There's what are called loose fibrous connective tissue and dense fibrous connective tissue. These are both fibrous connective tissues. Loose fibrous connective tissues are areolar tissue, reticular tissue, and adipose tissue. Dense fibrous connective tissues can be regular, irregular, or elastic. You also have your cartilages, which we're going to talk about in the next video. And then there are the special connective tissues, bone and blood. And each of these is actually going to get their own chapter, so we're not going to talk about them right now. We're going to talk about bone, later on when we talk about the skeletal system this semester, and we'll talk about blood when we talk about the cardiovascular system in anatomy and physiology too. So fibrous connective tissue. Why is it called fibrous connective tissue? Because the extracellular matrix, remember, connective tissue is all about the extracellular matrix, is primarily fibers. It has lots and lots of fibers, very few cells, or at least fewer cells than you would expect. What types of cells will you find in fibrous connective tissue? Well, the most abundant is going to be fibroblasts. Remember, blasts, let me actually put this in here. Blasts build. Blasts build. So fibroblasts build fibers. They're what makes the connective tissue. They produce fibers, collagen, elastin, reticular fibers, and they produce ground substance. So they build the extracellular matrix. You also find macrophages. Macrophages start off their life as a type of white blood cell called a monocyte. But when that monocyte moves out of your blood, it moves into your primarily connective tissues, and it basically eats things. They are your body's cops and garbage collectors. They wander around, and if they bump into something that doesn't belong, they eat it. And the term for that eating is phagocytize. Remember, cyto meaning cell, phago meaning mouth or to eat. They eat cells, or they are the eating cell. They eat foreign cells like bacteria or non-cellular things like viruses. They also eat debris, like things in your cells die, garbage accumulates. You have little bits of dead crap from maybe, a wound that you had. You've got some bits of scab that need to be gotten rid of, or maybe you have a bunch of cells that died fighting the good fight, fighting an infection. Well, all that stuff has to be gotten rid of. You can't just have it hanging around. And the macrophages are your garbage collectors. They're going to go grab all that stuff up, eat it, and then recycle it. So the macrophages are filtering, cleaning agents. They are also a part of your immune system. Leukocytes. Leuko means white, cyte means cell. So these are white cells or white blood cells. Macrophages, at least when they start off their life as monocytes, are white blood cells, but they eventually move out of the blood, in which case they're no longer blood cells. These are primarily immune system cells. Plasma cells. Plasma cells are a special type of leukocyte. These are the cells that make antibodies, and they will move to wherever the infection is. If the infection's in your blood, they stay in your blood. If the infection's in some organ, then they migrate to that organ and they make antibodies that will then act to do various nasty things to whatever the invading agent is, whatever the bad guy is. They can kill it directly, they can target it, and plasma cells come from a very special type of cell called a lymphocyte. Mast cells are also sort of part of your immune system. Mast cells you can think of as your body's alarm system. They're often found next to blood vessels, and they're found next to your body's barriers in mucous membranes and underneath your skin. And what they do is they monitor for anything that any tissue damage that might indicate that you now have an open path for infection, like you get a cut or something, that cut could get infected, or they monitor directly for infectious agents, viruses, bacteria, stuff like that. When they see those sorts of things, they secrete this special chemical, what's called an alarmone. It's a hormone that raises the body's alarm, called histamine. We'll talk more about histamine if you go on to microbiology and immunology. But basically, histamine is the thing that kicks off the body's inflammation response, which is the first step of the immune system. It raises the alarm, and that's going to attract all sorts of macrophages and leukocytes and plasma cells to that area to go fight the infectious agent. Since they respond to damaged blood vessels, and they're found next to blood vessels, they also secrete heparin, and heparin is, among other things, it is an anti-clotting agent. They keep your blood from clotting inside of your arteries, and your veins. You don't want blood clots to form unless there's an injury. Last, and these are usually only going to be found in a specific type of fibrous connective tissue, are adipocytes. Adipocytes, these are fat cells. Their primary role, most of the time, at least in adults, is to store triglycerides or fat molecules. So those are the cells that you might find in fibrous connective tissue. It's called fibrous connective tissue. What type of fibers will you find? You will find all three of the standard fibers: collagenous fibers, reticular fibers, and elastic fibers. The balance between them is what's going to make these connective tissues different. First type, areolar tissue. Areolar tissue is a loose connective tissue. Loose connective tissue means that the fibers are not super densely packed, and there's a bunch of space between the fibers for cells to move. So you can see that there's all of these cables running through here, and those are the fibers. But you also have a lot of fibroblasts, and they're moving around. You also have space for other things to move through. When you have blood vessels, capillaries, nerves, things like that, and they're moving through your tissue, the tissue that they're moving through more often than not is areolar tissue, because these cables are spaced far enough apart that you can basically squeeze stuff in between them. In areolar tissue, you'll find all 3 fiber types and all 6 cell types, but predominantly what you'll see is fibroblasts and collagen. Those are the main ones. Areolar tissue is usually spongy and soft. It's not super tough because, while it does have collagen in it, it doesn't have a whole bunch of collagen in it, because it's loose. But it is spongy, and it provides a cushioning effect. The fibers run in random directions, so it's going to basically resist force in all directions. Usually, areolar tissue will connect epithelium to other connective tissue types. So anywhere you find epithelial tissue, it is almost always resting on top of areolar tissue. Areolar tissue also has lots of leukocytes in it, and that makes sense because epithelium, well, everything that faces the outside is epithelium. If anything's going to get into your body, it's going to get in through the epithelium. It's going to end up in the areolar tissue, where you're going to have lots of leukocytes there to detect it and fight it off. How can you identify areolar tissue when you see it? Well, you will see usually the collagen fibers stain sort of a light pink, and they're very thick. So you can see these thick pink collagen fibers They're actually all around the background, so you sort of just see a pink smear a bit. These thinner, darker fibers, those are elastin fibers or elastic fibers, and you'll see lots of, they're just running random directions, but they're not super densely packed together, and you see lots of these amorphous cells with these dark nuclei just sort of scattered randomly about, but usually at a medium density. You also may see glands or blood vessels or things like that embedded in the areolar tissue. It's usually pretty distinctive. Second, reticular tissue. So reticular tissue is a loose connective tissue where the dominant fiber type is reticular fibers. And you can recognize reticular fibers because they usually stain very dark and thin, and you can see how they make all of these like squiggles, and they'll connect with one another. So they don't really run parallel, they don't even really run in random directions, but you'll see them lots of meeting up with each other. And remember, reticule means net. And you will also see a fairly high density of cells embedded in it. So the whole purpose of reticular tissue is to get lots and lots of cells hanging out together. The primary cell types are going to be fibroblasts, which make the extracellular matrix, and leukocytes. You can think of reticular tissue as being kind of like a singles bar for leukocytes. This is where leukocytes go to meet up with other leukocytes and hang out, usually, make antibodies and stuff like that. The reticular fibers make lots of handholds that lots of cells can hang on to, so you see a relatively high density of cells. You will see reticular tissue in organs that are optimized for dealing with the immune system, particularly your lymph nodes, your spleen, your thymus, and bone marrow. Those are all primary and secondary lymphatic system organs. We won't cover the lymphatic system until later, but those are all organs that deal, at least part of the time, with your immune system. Reticular tissue also often acts as a filter for the body. Like your blood or fluids will be filtered through this area. All of those fluids come in contact with a whole bunch of macrophages and other immune system cells where they can clean out any cell debris or any dead bits because they're garbage collectors, and where they can also monitor for any sort of sneaky invaders that are trying to get in. All right. First of our dense connective tissues is elastic tissue. Now, there's going to be a different type of elastic tissue, what's called elastic cartilage, later on. Don't get them confused. This is elastic tissue. It is a dense fibrous tissue. You can recognize it by, you see these thick pink fibers here. Those are collagen, but you see lots of these thinner, darker, squiggly fibers. They're not quite as net-like as the reticular fibers, but these dark, squiggly fibers, those are elastic fibers. Right? So, elastic tissue is usually intended to stretch in one direction, or at most two directions, not three directions usually. And so the function is to provide a stretchy, recoiling tissue, and the fibers therefore run parallel to each other. You know, they aren't just running off in random directions. They're all basically kind of running the same direction. High density of elastic fibers. The most common type of cell are fibroblasts, but you'll note that you don't actually see very many fibroblasts around here. That is because this is a dense connective tissue. Dense connective tissues don't have very many spaces for cells, so you just don't see very many cells in them. Like, this is a cell right here. There's probably a cell down here as well, but there aren't very many. And primarily the cells that are around are fibroblasts. They're there to repair any damage that goes on, to make new tissue when it happens. But mostly what's going on is the extracellular matrix. You don't have a lot of elastic tissue in the body. It is very specialized. It is for tissue that is intended to stretch, and to stretch a great deal. And you just don't have very many tissue types that are intended to stretch. And not just stretch, but to recoil with force. So they don't just get bigger, but they're like a balloon, they collapse back. Where you're most likely to see them is in the walls of large arteries, particularly the aorta. What happens is that your heart is going to, let's see here, so this is your aorta, which basically comes right out of your heart. And this is your heart down here. Your heart pumps blood, and it pumps all of the blood at once. And so, boom, a whole bunch of blood gets squirted out from your heart when your heart beats. That causes this tissue, which has to then be able to stretch to accommodate that increased load of blood. And then the tissue, the elastic tissue, recoils. And that forces the blood farther down. So the aorta particularly, but other large arteries as well. Lung tissue, like when you inhale, your lungs fill up and the tissue stretches. When you exhale, a normal exhalation actually doesn't use any muscles. And all the force that you need is your diaphragm relaxing and the elastic tissue that surrounds your lungs basically squeezing down, sort of like you let the air out of a balloon. You don't need to squeeze the balloon itself will collapse and force the air back out. You'll also find some elastic tissue in ligaments. Ligaments in general have more elastic fibers than tendons do. And that's because tendons are used to move bones. When your muscle contracts, it needs to take the bone with it. So if you were like hauling on something, like let's say you've got a big rock here, all right, and you tie a rope around the rock. Well, when you pull that rope, you don't want any stretch in that rope. You pull the rope, the rock should move. All right? Ligaments connect bones to other bones. They aren't primarily there to move each other, but to keep two things connected. And let's say you had two things that you wanted to be connected to one another, and you're not so much concerned about like being able to force them along, but you want them not to break apart. Well, the thing about a rope is it doesn't want to stretch. It's strong, so it usually doesn't stretch, but if it does stretch, it usually tears. So you'll tear a tendon pretty easily. Ligaments are a little bit more stretchy. They're kind of like bungee cords. So you can like stretch these two things out a little bit. Your bones have a little bit more pull, and then they'll recoil back into place. It is still possible to pull a ligament. Their ligaments are still mostly collagen, but they do have more elastic tissue in them. Onto that, so dense regular connective tissue. Dense regular connective tissue is, it's dense, meaning it's mostly extracellular matrix with very few cells. It is regular. Regular means that all of the, or most of the collagen fibers are headed in generally the same direction, right? So you can see here in this tissue, these are the collagen fibers, and they're all going pretty much parallel to each other. It's dense, so you don't see very many cells. This is a cell, this is a cell, there's a cell here, a cell there, but it's mostly extracellular matrix. The point of dense regular connective tissue is it's collagen, so it's very, very strong. And having all of the tissues run, or all of the fibers run the same direction, that makes it super duper strong in that one direction. So you could pull really, really hard that way or that way, and it would not break. Not break very easily, at least. So this is why your tendons are made out of dense regular connective tissue. Your tendons and most of your ligaments are made out of dense regular connective tissue. Your tendon really just needs to pull your muscle or your bone the one way. It needs to pull it the direction the muscle is pulling it. But that means that they are weak to shearing forces. So a force this direction or that direction, that's going against the grain of the fiber, and it's weak that way. So how do you spot dense regular connective tissues? Densely packed collagen fibers, all running the same direction. Some dense regular connective tissues will have elastic fibers in them as well, ligaments, for instance. And all of the fibers are running parallel with each other. They may be running straight, or they may be going on a squiggly path, depending upon how many elastic fibers are in there. And you won't see very many cells, and when you do see the cells, they're going to be flattened out between the collagen fibers, right? So the collagen fibers are all running next to each other. You basically got to squeeze the cells in between them. Where do you see it in the body? Tissues that resist large amounts of force in a single direction, particularly tendons and ligaments. Next, we have dense, irregular connective tissue. This is much the same as dense regular in terms of its composition, but it looks dramatically different. So again, it's going to be densely packed collagen fibers. These thick pink fibers, those are collagen. But instead of all of the fibers going the same direction, here we have all of the fibers going random directions. This one's sort of squiggling its way down. Here we see one that's going off that way. And you'll see ones, because this is a slice, remember, here we've basically got one that's just going into the plane of the screen, the plane of the slide. Here it'll like run parallel a little bit, and then it'll move out of the slice that we're looking in. So you get a lot of stuff that looks like basically like kind of, squiggly pink worms. Because the fibers are not all parallel to each other, that means that the cells are going to be less squished. So you see here, this is a fibroblast up here, fibroblast down here, fibroblast over here. But it's dense, and it's mostly extracellular matrix, so you still don't see very many cells. When you do see cells, they tend to be fibroblasts. Dense irregular tissue is found in any tissue where it needs to resist a lot of force, but you don't know what direction that force is going to come from. Could come from any direction. This is particularly found in the dermis of your skin. So your skin needs to be able to resist tearing force, because if your skin gets teared, that's bad. But you don't know which direction that force is going to come from. It's on your skin. It could come from anywhere. So irregular connective tissue is not as strong as connective tissue or as regular connective tissue, because you don't have all of the fibers lined up, but it is more versatile. It can resist force that is pulled in any direction. It's fairly common. It's found in the dermis. It's found in a whole bunch of other tissue types that have to connect things together. It's found in, inside of your muscles, connecting muscle fibers together. Found connecting cartilage together, inside nerves, binding all of your nerve fibers together. Other organ capsules as well. Very, very common type of tissue. You'll also sometimes see glands, which, remember, are epithelial tissue, and sometimes blood vessels. Usually blood vessels will run through like dense irregular connective tissue, but they'll be all bundled together, and then when you hit the areolar tissue, they'll branch out and you'll suddenly get a whole bunch of them. But you do get blood vessels running through dense irregular connective tissue, as well as glands and nerves. Last, and this is, it's a little bit unclear whether you would call this a dense connective tissue or a loose connective tissue or a special connective tissue. I'm calling it a loose fibrous connective tissue for our purposes, and it's adipose tissue, right? Adipose tissue, you can see, is mostly cells, and the cells are mostly these big empty globs with a nuclei on one side. The reason is because the stains that allow you to actually look at this don't stick to fat. They're water-soluble stains. So the fat portion just looks like a big empty area. And then you can see a little nuclei that stains on the side of them. Large bubbly cells, and they have reticular fibers connecting them. So these fibers that you see in between here, those are mostly reticular fibers. They form this net in which the adipose cells exist. It's fairly loosely packed. You can have blood vessels, nerves, those things move through this area very, very easily. The function of it provides cushioning protection, so protection against, force, energy storage in the form of fat, insulation, right? So many animals, and to a certain extent people, who live in very cold climates will develop thick, fatty layers underneath their skin that helps them hold in body heat. And in small mammals and very, very, very tiny humans, heat generation. Not just insulation, but actually making heat in something called brown fat. So they look empty with a compressed nucleus at the edge of the cell. I think they look kind of like little bubbles, little fatty bubbles here. Yeah, that's adipose tissue. So those are the fibrous connective tissues. Bullet points. What do you need to know? So for each of the tissue types talked about here, you need to know what type of cells are found in them, what type of fibers are found in their extracellular matrix, the arrangement of the fibers, loose versus tight, parallel versus random. You need to know the function of that tissue and where that tissue would be found in the body. And for lab, you should be able to recognize that tissue on a slide or picture of cellular material.